this is the first part of the Pearson's Edexcel GCSE Mathematics Paper 2 Calculator Foundation Tier paper for June 2017. Let's begin. So the first question says 5p minus 3p plus p. So we're asked to simplify. So 5p minus 3p plus p. So if we're thinking about BIDMAS, then we would deal with addition first. So 5p minus 2p, and then that will give us 3p. And then we simplify m to the power of 3 plus m to the power of 3. So same base, same power. So that would be 2m to the power of 3. And then it says here, simplify 10 plus 3c plus 5d minus 7c plus d. So let's collect the like terms. This is a number or a numerical value, and all the others have variables and coefficients. So that's 10. So this is 3c and minus 7c. And we have 5d and d, right? So let's start with 5d plus d equals 6d. And then we said 3c minus 7c. So that's minus 4c. And then we can write our 10. So all in all, we will have 10 minus 4c plus 6d. Question 2 says, write 56.78 correct to one significant figure. So we can see that the number 6 is above 5, of course, so we can round up. So 60. Okay, question 3 says, a teacher asks students in year 6 what type of transport they use to get to school. The dual bar chart shows some of the results. So let's look at this graph very quickly, or the bar chart very quickly. So frequency on the y-axis, and then here on the x-axis on the horizontal, we have the mode of transport. So this is the key. So boys is in filled, and then girls is sort of sketched diagonal lines. So the question A says, what is the most popular type of transport used by boys? So looking here, you can see that it's going to be walking. And then it says 7 girls walk to school. Show this information on the dual bar chart. So walking here, we know that girls is going to be these diagonal lines. So then we go to 7. And again, excuse the fact that my line is not straight. It does matter, but just because I don't have the capability of drawing a straight line, I'm going to emphasize that they should be straight edges. So hopefully just by me telling you that, you should appreciate how it should look visually. And it says more of the students get to school by car than bus. So how many more? Okay, well, let's look at our graph. A bar chart. So we can see that there are 5 boys and 9 girls that take car, and there are 6 boys and 4 girls that take bus. So let's record that information. So car, so 9 plus 5 equals 14, and then bus, 6 plus 4 equals 10. So using that information, 14 minus 10 equals 4. So 4 more. It says, what's the total number of... So the number of students in year 5 is the same as the number of students in year 9. So what's the total number of students in years 5 and 6? Okay, so that means we've got 14 here, we have 10 here, we have 9 plus 7, so 16. So let's just capture that information. So we've got 14 here, we've got 10 here, 16, we have 5 here, and 3 here. So if we add all of that up, our answer will be 48. So I'll just put somewhat of a asterisk over here. So let's see, working out above, and then we can put our answer 48 there. So question 4 says, here are 4 fractions, 2 over 5, 11 over 30, a half, and 7 over 15. Write these fractions in order of size. Start with the smallest fraction. So the first thing that you'd ideally want to do is work out the lowest common multiple in order to change the denominators so that they're all the same, which will enable us to change the numerators accordingly and compare against one another. So let's just put that into words. So let's take the largest number, 30. So I can see that all these numbers, 2, 15, 5, are factors of 30. So 2 over 5, if I change that to 30, well, I know I've multiplied by 6. So multiply by 6. So I get 12. Then 11 over 30, well, that's just going to stay the same. Then I've got a half. So I know I've multiplied by 15. Multiply by 15 here. So I get 15. And then 7 over 15, if I'm going to change that to have a 30, so I've multiplied that by 2, multiply this by 2, so I get 14. So that means that now I've got, so 12 over 30, 11 over 30, 15 over 30, and 14 over 30. So which one working? Start from the smallest. The smallest. So look at the numerators. So this one is going to be the first one, and then we're going to have this as a second, and then our third, and our fourth and final. So if we write out in its original form, so we'd say 11 over 30, and then 2 over 5, and then 14, sorry, 7 over 15, and then a half, and that will be our sequence in terms of order size from smallest to the largest. Question 5, it says David sells CDs in a shop. The tally chart shows information about the number of CDs David sold on Monday, on Tuesday, on Wednesday. So you have that information there. That's a tally, and that's frequency. So if you add all of these lines up, this is 5, 5, and that's 3. So it should add up. So that 12 leads me to believe that this, so looking at this question here coincidentally, so write down one thing that is wrong with the tally chart. So first thing instinctively, Monday has been incorrectly added. So then it says David drew his pictogram to show information for Tuesday and Wednesday. So it says write down one thing that is wrong with the pictogram. So this is your key. So this represents 3 CDs. So this is, let's calculate them. Start with the smallest one. So 3, 6. So 6 and 1.5. Well, that's going to give us 7.5. But on Wednesday it was 8. So obviously it says that that's wrong. So on Wednesday, so there are 7.5 CDs sold. So you obviously you cannot sell half a CD. So question 6 is different color. Says there are 495 coins in a bottle. A third of the coins are £1 coins. 124 of the coins are 50p coins, and the rest of the coins are 20p. So work out the total value of the 495 coins. So I'm just going to do something I've recommended before. Just highlight the information that we have. So a third are £1 coins. So 124 are 50p coins. And then it says the rest are 20p coins. Okay. Right, so let's do this. So we want to work out 495 divided by 3, so to figure out a third. So that equals 165. So we know that 165 coins are £1 coins. So that means that there's going to be £165 worth of £1 coins. And then we know that 124 are 50p. So that means that the 50p coins equate to £62. And then it says that the rest are 20p. So we've got 165 plus 124, and then all of this is going to be subtracted from 495. So that will give us in total 206. So we know that 206 coins are going to be 20p coins. So therefore 0.2 times 206 is going to be 41.2. So now we can add up all of our values. 165 plus 62 plus 41.2, which will give us a total of £268 and 20p. Just write that in there. So £168 and 20p. Question 7. It says the probability that a new fridge has a fault is 0.01. What is the probability that a new fridge does not have a fault? So the probability that the max probability you can get, so max is 1. So probability that has a fault is 0.2. So I'm going to put P fault 0.015, and probability of no fault It's going to be 1 minus 0.015, which gives us 0.985. Okay, question 8. It says, here is a list of numbers. From the numbers in the list, write down the square number. Write down a square number. So a square number, remember, is any number that can be square rooted to give us a integer. So in this case, can't square root that to give us an integer. Keep going, keep going. Oh, there we go. 25, because 5 squared, just instinctively I know from doing this many times, 5 squared equals 25. So 25. From the numbers in the list, write down a number that is both a multiple of 4 and a multiple, multiple of both 4 and 6. Well, I can just do 4 times 6, 24. So I know that the number is going to be 24. And then write down all the prime numbers in the list. So let's go through it. So this can be divided by 7, can be divided by 2, 23. Okay, so that's our first prime number. So it can be divided by 2, can be divided here by 5, can be divided by 2, can be divided by 9, can be divided by 2, 29. Okay, so that means that 29. Okay, question 9 says find the value of x. So you can see that we have, first of all, this right angle. And we know that this full turn, okay, will give us 360 degrees. So we've got 2x plus 3x plus 90 will give us 360 degrees. So if we collect like terms, 5x plus 90 equals 360. So we can take this to the other side, becomes a minus 90. So 5x equals 270. And then if we divide through by 5 on both sides, then this will give us x equals 54. So that will be our answer, 54 degrees. Change color. Question 10. Suha is going to buy 150 envelopes. Gonna start. Okay, and she has these two options. Letters to send. Pack of 25 envelopes for £3.49, and pack of 10 envelopes for £2.10. For 2 packs, you get 1 pack free. And she wants to buy 150 envelopes as cheaply as possible. So let's work it out. So let's do our letters to send. So we want to buy 150. Divide that by 25, which is in 1 pack. So that will give us 6 packs. So 6 times £3.49, which is what 1 pack costs, is 20.94. And then separate this. So pack of 10 envelopes for £2.10. So if you buy 2 packs, you get 1 pack free. So that means for 30 envelopes, you get, it's going to be a cost of £4.20. So 150 divided by 30 is going to be 5. So 5 times 420. And that gives you 21. So that means that letters to send is the cheapest. So to send. So cheapest or best value for money, or whichever way you want to put it. Okay, let's just zoom out for this one. Different color. So it says you can use this graph to change between inches and centimeters. So this is like a conversion graph. Change 74 centimeters to inches. So we've got on the x-axis, sorry, on the y-axis we've got centimeters. On the x-axis we've got inches. So I'm just gonna call that up, have it y and x. Anyway, so we have to be very careful because with these graphs the spaces are not always distributed the same. So here you can see each box represents 1. However, each box here represents 2. So you can see that you have to take that into consideration. So it says change 74 centimeters to inches. So 74. So is here. So if we just follow that line, come about here, and then we'd go all the way down, and it would come there. So that is 29. So usually you'd have a ruler to make sure that you draw a straight, or at least you trace a straight line going from the axis to the line, and then once again from the line to the axis. But just because my lines aren't straight on this, you can just follow the cursor and see that it works. So it says Daniel's height is 6 feet and 3 inches. So 1 foot is 12 inches. And what is Daniel's height in centimeters? Okay, so we know he's 6 feet. So 6 times 12 gives us 72 inches. And we know he's got the 3 additional inches. So 2 plus the 3 would give us 75. And then we know that, so going back to our graph up here, so 50 inches, so here are the inches, so 50 inches, follow all the way up, and then we would, let's just zoom in, sorry, just do that, so zoom in, so you can see that in this case the line is actually halfway through the square. So if we go all the way across to the other side, it's going to end up here. So this is 127, there's 126, 128 and 130, so that's 127. So the 50 inches equals 127, and then 25 inches, which together make up the 75, is going to be, so we just go back up. So again, this is 25 inches, go all the way up here, and then again, same thing, it's about halfway through. And if we go here, it gets to 63. That's 62, and then that's 63. Centimeters. So if we add these two, we get 190. So 190 centimeters is our answer. So question 12, it says, find the value of this equation and write down all the figures in your calculated display. So if you put this down in your calculator display, you will get the following answer: 0.07333035981. So remember, the trick here isn't writing down the answer you get in the calculator, but making sure that you've pressed the right buttons into the calculator first. So what you would do is, let's say the numerator, so you'd put in 13.4 minus 1.5 squared, and then you'd divide that by 6.8 plus 0.06 squared. I'm going to put that in its own brackets, and then you would get the answer. Question 13, it says rotate shape A 90 degrees clockwise about center 0. So this is something that I wouldn't be able to show you offhand, but we know that it's rotating around center 0 origin, and then 90 degrees clockwise, so clockwise about that way, 90 degrees. And if you were to plot it correctly, you would have, and I'm just going to draw it for you, with straight edges, of course. And again, this should be straight edges. Just going to put a dash. So please forgive me if they're not straight, but you can appreciate what I'm trying to get at. And then it says for part B, so describe fully the single transformation that maps triangle B onto triangle C. So essentially, what's the transformation that maps this onto that? Well, it's going to be a reflection in the y-axis. Okay, so in this axis, where x equals 0. So reflection in y-axis, so where x equals 0. Question 14. So it says factorize 5 minus 10m. So we want to factorize out the commonality between these two terms. So I have a numerical value here, numerical value here. So we can see that 5 and 10, well, the 5 is a factor of 10 and 10 is a factor of 10. So let's say 5, 1 and 2m, and it says factor fully 2a squared b plus 6ab squared. So let's look at the numerical values first. So 2 is a factor of 6 and a factor of itself, so take that out. So we have a squared here, we've got 1a there, so we've got a is common between them, and b here and b squared here, so we have b to the power of 1 that's common between them. So let's open the brackets up. So what do we have left? Well, we've got a left, and then on this side we have the 3, because 2 times by 3 will give us that original 6, and then we had b left. Question 15, it says write 4.7 times 10 to the power of minus 1 as an ordinary number. So this is times 10 to the minus 1. So 4.7, it can be written as that, which will equal 4.7 divided by 10. So that means that decimal point goes to the left by 1. So 47. Work out the value of this here, giving your answer in standard form. So you can essentially put this into the calculator, and if you do so, you will get the answer as follows. So 228, and then it will be followed by 7 zeros. So 1, 2, 3, 4, 5, 6, 7. So that's 2,280,000,000. And then if you put it in standard form, so you would write it as 2.28 times 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of 9, because our decimal point is between the two twos. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our answer. Okay, question 16. It says A, B, and C are 3 points on a map. 1 centimeter represents 100 meters. Point T is 250 meters from point A. And point T is equidistant, which equidistance means it's in the middle of, or sort of equally distant from, point B and C. And on the map, show one of the possible positions for point T. Now, obviously, I can't show this on the screen just because I don't have the capacity to draw straight lines, and I don't have a compass at hand to demonstrate on the screen, but I can explain it to you. So essentially, you get your compass point here, and you would draw your, put the point there, and you would draw something out, sketch something out. And again, this is very rough. And then the same thing for point C. You get your compass point there, and you would draw it out, look something like that. And we know that point T is 250 meters from point A. So 250 meters is 2.5 centimeters. So that's now a radius of A, or the circle A. So if we take that point there and we draw out a circle, so again, this is going to be a very rough looking circle, please excuse it. And then it says that now we have all the points. We can see that T will be there. Okay, so point T, if we draw, so these are the 2 points where C and B have marked out the intersections. If you draw the straight line, it will be equidistant at any point on this straight line, and it is always 2.5 centimeters away from the circle. So we cross it there, and that is our point T. Question 17. The table shows the probabilities that a biased dice will land on 2, on 3, on 4, on 5, and on 6. Neymar rolls the biased dice 200 times. Work out an estimate for the total number of the times the dice will land on 1 or 3. Okay, so this one we need to fill in. So we know that the so max probability equals 1. So it's going to be 1 subtract 0.17, 0.18, 0.09 minus 0.5 minus 0.1. So that's going to give us P1. So P1 is going to be 0.31. 0.31. So it wants to work out the estimate for total number of times dice will land on 1 or 3. So what's the probability? P1 or P3. So that means it's going to be 0.31 plus 0.18, which is 0.49. So it's spun. It's rolled 200 times. So 200 times 0.49 gives us 98. So that's the probability. That's the amount of rolls we've had. So the answer is 49. The estimated estimated total number of times dice will land on 1 or 3 is 98 out of 200. So question 18. So it says, on Saturday some adults and some children were in the theatre. I'm gonna start highlighting things. There's a lot of stuff here to be read. The ratio of the number of adults to children was 5:2, and each person had a seat in the circle or had a seat in the stalls. 3/4 of the children had a seat in the stalls, and then 117 children had a seat in the circles, and there's exactly 2,600 seats in the theatre. So on this Saturday, were there people on more than 70% of the seats? So I guess that's the exam question, if you like. So were there more than 60% of the seats? Alright, so let's figure that out. So we know that 5 plus 2 gives us 7. So there's 7 parts to this. 5 and 2 from the ratio. So that means 5 over 7 parts were adults. And then 2 over 7 were children. And then we know that 3 over 4 of the children had seats in the stalls. So 3 over 4 in stalls. That means that 1/4 were in circle, and it says that if we multiply, so 2 over 7 times 114, we get 2 over 28, which simplifies as 1 over 14. So 1/14 children in circle. And then we know that 114 equals 117 children in the circle. So it's given, that number is given to us. So that should be equal to 117. Right? So that means that if we want to find out the total number of children, total number of people, then it's going to be 117 times by 14, which gives 1,638. So come back here, 1,638. We know there's 2,600 seats, and times by 100, so that gives us 63%. So that means that yes, more than 60% of seats had people on them. Brilliant. Okay, question 19 says the diagram shows prism with a cross section in the shape of a trapezium. So on the centimeter grid below, draw the front elevation and the side elevation of the prism. Use a scale of 2 centimeters to 1 meter. Right, so basically it's saying that each one is 1 meter. So if you use 2 centimeters, that's 1 meter. So 1 centimeter, 2 centimeter, which will give you 1 meter. So essentially each one is 0.5 meters. Okay, so let's draw. So this is the front. It's telling this is the front face, and then this is the side face, or view, however you want to put it. So if we want to draw the front first, so let's draw the front first. So we know that the front facing side, this is going to be 2 meters, and if each one is 0.5, that means we're going to have 4. So 1, 2, 3, 4. And then the same thing, so 1, 2, 3, 4. And then we've got 0.5, so it's going to be that. Connect that up, brilliant. And then if we have the side, so same thing. So this is 1 meter. So that's 2 boxes. And then it goes up. If you're looking at it from the side, it goes up by 2 meters. So that's that. Same thing. Oh, let me just rub that off. I know it's not straight, but that's just nowhere near good enough. So do that, connect that. So essentially it's meant to be crossing the edges straight. And then you can see we have this line here at 0.5, so that needs to also come across there. So again, obviously I can't draw straight lines, but as long as I tell you that these lines should be straight and they should be going, you're tracing across the borders. Okay, question 20. So there's quite a bit of information here. Let's summarize it. So Ollie drove 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. His average speed from Liverpool to Manchester was 70 kilometers per hour. And then Ollie took 75 minutes to drive from Manchester to Sheffield. So work out his average speed for his total drive from Liverpool to Sheffield. Let's just highlight some stuff here, just so we know what we're dealing with. So that's the first part, Liverpool to Manchester. And then this is Liverpool to Manchester. And then I'm going to highlight this and highlight that. So all the relevant stuff I want to highlight with one another. And then essentially it wants from Liverpool to Sheffield. And it's broken up from Liverpool to Manchester, then Manchester to Sheffield, so into 2 parts. So remember we had the distance, speed, and time, so that triangle. Right. So let's do L to M. I'm just going to use the initials. So the time it took him, so time was 56 over 70. So 4 over 5 equals 48 minutes, because we have 4 over 5 times by 60, which equals 48. And then so M to S, probably use a different color here. So M to S, so it took him 75 minutes, and so the total distance was 56 plus 61, and then that's 117 kilometers. And then the total time, so we'll do that. So total time was 123 minutes, which is, you can change that to 2.05 hours. So the average speed, so average speed was 117 divided by 2.05, which is 57.07, and so forth. So if we round to two significant figures, we get 57 kilometers per hour. So just to recap, essentially what we've done is we know that it travels 56 kilometers, and the average speed from Liverpool to Manchester was 70 kilometers, which is 405. And we know that 405 times by 60, because we're dealing in hours here, so 1 hour 60 minutes, gives 48 minutes. That's how we got that. So we probably should do this. And then so the total distance was 56 plus 61, which is 117, and then total time was 48 plus 75. So we convert that into hours, 2.05 hours, because we want our answer in hours. So 117, so kilometers, divided, that forward slash is divided sign, by hours, so 2.05, which gives us 57.07 and so forth. So two significant figures, 57 kilometers per hour. So the next part is Jamie drove from Barnsley to York. Oh, Janie drove from Barnsley to York. Janie's average speed from Barnsley to Leeds was 80 miles an hour. Her average speed from Leeds to York was 60 kilometers per hour. And then Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers an hour and 60 kilometers per hour. So if Janie is correct, what does this tell you about the two parts of Janie's journey? So that means that, if she's correct, that means that the time must be the same. Okay. So question 21. So again, we have one of these shape questions. So A, B, C, and E, D, C are straight lines. E, A, and D, B are parallel, and you can tell because of these arrowheads pointing in the same direction. And then you also said EC equals 8.1, so that whole thing is 8.1. I'm just going to put that there, centimeters. DC is equals 5.4, and it says DB is 2.6. So it says work out AE. So what is AE? So I'm going to put a X there. Right, so what we can use here is scale factor. So we can say, scale. So we can say that since the whole thing from E to C is 8.1, and this D to C is 5.4, scale factor of 1.5. So this line is 2.6, times it by 1.5, you're going to get 3.9. So the answer is 3.9 centimeters. So X will be 3.9. Okay, and again, it's just to do with scale factor. Just drawing out these lines to make it look a little bit more clear. Okay, so the next part is AC equals 6.115. Use a different color here. So AC 6.15, so 6.15. Okay, work out the length of AB. So again, very similar. So just scrolling down ever so slightly. So BC, which is here, is going to equal 6.15 divided by 1.5. So that gives us 4.1. So AB equals 6.15 take away 4.1. So AB is that part and BC is that. So BC, so 4.1. So that's going to give us 2.05. Question 22. So Anil wants to invest 25,000 for 3 years in a bank. He's got his personal bank and secure bank. Compound interest, so 2% for each year, and compound interest 4.3% for the first year and 0.9 for each extra year. So which bank will give Anil the most interest at the end of year 3? So I'm just going to highlight some stuff for myself. So I think it's important. So 3 years, so 2%, it's 4%, 0.9 for the following year after that. So what we're going to do is use the compound interest formula. So we take 25,000 multiply it by 1.02 to the power of 3. Remember, so the initial figure is 25,000, excuse that, and we have over 3 years, so that's the initial times by 1.02, so 2% is 0.2, and then we want 3 years, so to the power of 3. Okay, so that will give us, if you put it in a calculator, so you'll get 26,530 and 20 pence. And then, so that's for personal bank. We'll use a different color for secure. So secure bank. So the same logic. So 25,000 times by, so first you can do 1.043, because remember here is 4.3% for the first year. Then you're going to multiply by 1.009, so which is 0.9%, refers to that, to the power of 2 for each extra year. And because it's a total of 3 years, so 1 year refers to this, and then the subsequent 2 years refers to that. So you will get 26,546 pounds and 46 pence. So which one gives you more? Essentially secure bank. Okay. Question 23. So a number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval for n. So basically, if you draw a straight line and it says the result is 4.76, so that's 4.77, and it's going to have 4.75. So where you would round it up use a different. Is 4.755, and you would round it down from, or rather 4.765, so it would be rounded up to this from that point. So you say 4.755 is less than or equal to n, which is greater than 4.765. Although you could also say 4.755 n is less than or equal to 4.764. And I mean, if you wanted to play around with the inequalities, so you'll get different things. And then question 24. So we've got this quadratic here, x squared plus 5x minus 24 equals 0. So essentially we want x that satisfies the rule, so that satisfies the quadratic. So we could use the product sum method here. Product sum method. So I can look at this instinctively and I can say that my x, which is going to follow this rule, could be minus 3 and 8. So let's put them into this factorized form in bracket. So x plus 8x minus 3 equals 0. So that implies that x equals minus 8 and x equals 3. And the final question, 25. So here are the first 6 terms of an arithmetic sequence: 3, 8, 13, 18, 23, and 28. So find an expression in terms of n for the nth term of the sequence. So the best thing to do is to take the differences. So 5, 5, 5, and you know they're all going to be 5 because arithmetic. So it's going to be 5n. And then, well, we're going to subtract 5 from that. Subtract by 5, which gives us minus 2. So if we go back 5, we get minus 2. So minus 2. So our total answer will just be 5n minus 2. So that's the expression. And then it says the nth term of a different sequence is 3n squared. Nathan says the fourth term of the sequence is 144. Is Nathan right? Show how you get your answer. So 3n squared. He says the fourth term, so that means n equals 4 in this case. So 4 squared, which is 3 times 16, which would give us 48. So unfortunately, so no, Nathan is wrong. And that's the end of this paper.